Okay, so just a few things here, mostly problem solving in section 9.10 with trig ratios. They're going to introduce a little bit of vocab for what's called angles of elevation or angles of depression. Angle of elevation we'll start with first. Suppose my eyeball is at E and I'm looking up at some object above me, and elevation will assume we're going up. We measure an angle of elevation with the nearest line of sight with the nearest horizontal. So my angle of elevation here in this case is going to be right there. Now we also have, they're going to talk about what an angle of depression is. An angle of depression means if you're looking at something, you're looking down at it, relatively speaking. And let's suppose someone else's eyeball were up here at S and they were looking down on me down here at E. That would be looking down. And an angle of depression also is measured to the nearest horizontal, which would be right here. So relatively speaking, from a point where I'm looking at an angle of elevation, there's always going to be an associated angle of depression from that top point looking down on me. And since horizontal lines are parallel, we then can see from our alternate interior angles that an angle of elevation and an angle of depression are going to be congruent alternate interior angles. And again, reminder, angles of elevation and angles of depression are always measured to the nearest horizontal line. Okay, so situation here that we can look at an application of trigonometry to solve a question that actually is fairly interesting. Let's suppose I have a mountain here, and I'm standing here at point A, and we'll assume level ground here right through the base of the mountain. And I'm interested, I look up and I see the top of the mountain, and I'm interested in, relative to me to this level ground, how tall is the mountain? I am able to measure an angle of elevation here. And let's suppose my angle of elevation here at point A is 30 degrees. And I then move 100 feet closer and I look at the top of the mountain. And now my angle of elevation is 45 degrees. And I'm interested in how tall is the mountain. To do that, I've got to see here that I've got some right triangles. I have two right triangles. Let's put point B here first. We have point B here. First right triangle is going to be here. And it's going to have dimensions of, well, I don't know how far it is from B to the base here. I don't know what that length is, so I'm just going to call that X. So then I've got H and 100 plus X, and I've got my 30 degrees here. I have another triangle. I have another triangle as well, and that triangle runs from B and H. I got a right triangle here, so that right triangle looks something like this. Dimensions are H, here's my right angle, this is X, and this was 45 degrees. The question is that enough information? Do I have enough information with these two diagrams to solve for H? So, if I look at relative to the acute angle in each right triangle, I've got the opposite leg and the adjacent leg. So I can set up a trig ratio here involving H's and X's and those angles. So the tangent of 30 degrees equals H over 100 plus X, and the tangent of 45 degrees equals H over X. And now I want you to look at what you have here. You have two equations and two unknowns. Note the tangent of 30 and tangent of 45 are numbers. The tangent of 30 from a 30, 60, 90 triangle is the following. Tangent of 30, if I draw my 30, 60, 90 triangle, here's my 30 degree angle here. Opposite the 30 is X. Opposite the 60 is X root 3. So my tangent of 30 degrees is x over x root 3 equals 1 over root 3 equals root 3 over 3. And the tangent of 45 degrees, much easier to do for the 45, 45, 90 triangle. Tangent is going to be leg over leg. So the tangent of 45 is 1. Okay, so looking at, again, our two equations here that we've got. Two equations, two unknowns. If I solve the second equation here for x, because I want to have stuff with just h's. In this case, it turns out I made the numbers work out nicely. X equals h, and then if x equals h, I then can plug into my first equation here, get rid of the x, and then I've got root 3 over 3 equals h over 100 plus h. Now all I need to do is solve for h, and let's look at the algebra behind that. If I do means extremes product theorem, I get 100 root 3 plus h root 3 equals 3h. Get everything with h on one side, and then I get 100 root 3 equals 3h minus h root 3. Factor an h out, 100 root 3 equals h times 3 minus root 3, and then divide each side by 3 minus root 3. So 100 root 3 over 3 minus root 3 equals h. And if I want, I could go on my calculator and get a decimal approximation for that height in feet of my mountain. Okay, so here's the situation. Suppose I'm given two sides of a right triangle, 4 and 7, and I'm interested in that acute angle A that's opposite the leg of 7. I want to know the measure of that angle. Well, I do know that the tangent of that angle is opposite leg over adjacent angle, which is 4/7. My calculator is a button called the tan inverse button, inverse tangent button, or tan to the -1, or arc tan. And we've got a whole bunch of notations for this process. Sometimes you'll see it as arc tan. Sometimes you'll see it as tan -1. And what this notation allows me to do is solve for that angle A. So again, if I know the tangent of A equals 4/7, the tan inverse of 4/7 equals A. And note what's happened. I've just reversed my 4/7 and my A with that notation. The calculator, if you put in tan inverse of 4/7 and you make sure you're in degree mode, you can hit your mode button, make sure you've selected degrees. Tan inverse of 4/7, it'll pick the angle between 0 and 90 degrees that has a tangent of 4/7. Now, this tan inverse also, you should be wondering, does it work also for sine and cosine? And indeed it does. Suppose I've got sine of A is 0.3, then the sine inverse of 0.3 will be A, and suppose I've got cosine of A is 0.8, then the cosine inverse of 0.8 will be A degrees, the measure of A. So that's it for section 9.10. Some problem solving, and you should enjoy these problems. They're fun.